Chapter 4, Section 14, Outlier Detection. Handling outliers is an important process in data analytics. Datasets often contain anomalous values known as outliers that significantly differ from other data points. These outliers can distort analysis results or lower the accuracy of model predictions. Therefore, we need to handle outliers properly. As the first step, this section will focus on the primary methods for outlier detection. An outlier is a data point that is significantly different from other observations in a dataset. It deviates markedly from the overall pattern or distribution of the data. Outliers can occur due to various reasons such as measurement errors, data entry mistakes, genuine variability, or rare phenomena. The definition I have just proposed says that an outlier is a data point that is significantly different from others. But significantly different is ambiguous as a rigorous definition. Can we define an outlier more rigorously? No, the definition of an outlier is context-dependent and not strictly fixed. While we can use some statistical guidelines to define outliers, the boundary between outliers and normal observation is often affected by domain knowledge and the purpose of analysis. As to domain knowledge, in some fields, what constitutes an outlier depends on practical considerations. For instance, in finance, extreme stock prices may not always be treated as outliers, but rather as contextually important observations. The definition of an outlier also varies depending on the purpose of analysis. For example, in customer churn prediction, outliers in purchase frequency can distort the model and may need to be removed. Conversely, in anomaly detection, outliers in purchase frequency are precisely the points of interest. Outliers should not always be removed, as there are various ways to handle them. However, the first step is to detect outliers. Outlier detection methods differ depending on whether we deal with one variable, multiple variables, or time series data. In this section, we will focus on methods for detecting outliers in one variable. We can detect outliers using statistical methods, while also using knowledge and considering the goals of analytics. Common statistical methods for outlier detection include z-scores and IQR. Before identifying individual data points as outliers, it is also effective to use visualization techniques such as box plots and histograms to check whether outliers exist in the data. Visualization is useful to obtain an overall understanding of the data. The z-score measures how far a data point is from the mean of its distribution, expressed by standard deviations. Using z-score is particularly effective when the data approximately follows a normal distribution. The z-score is calculated using this formula. The z-score standardizes the value of each data point by representing how many standard deviations it deviates from the mean. Typically, the criteria for identifying outliers is that an absolute z-score is greater than 3. In a normal distribution, 99.7% of data falls within the range where the absolute z-score is less than or equal to 3. The concept is to consider data points outside this range as outliers. When the data does not follow a normal distribution, the interquartile range method is effective. This method is called Tukey's method. The IQR is the difference between the third quartile and the first quartile. Combining the first and third quartile and IQR, set the lower bound and upper bound by this formula. Typically, outliers are identified by detecting values that fall outside this range. Let's use this simple dataset to detect outliers by Python. This dataset consists of 10 data points. First, import the libraries and prepare this dataset. Make sure to import z-score from scipystats to compute z-score efficiently. First, let's create a histogram to see the data distribution. As we can see from the histogram, the data does not follow a normal distribution. Additionally, there are bins that are far apart on both sides, so there are likely some outliers. First, let's detect outliers using the z-score method. To calculate the z-score for each observation, we select the relevant column and apply the z-score function. The focal variable is named value. Let's store the z-scores in a new column named z-score. Next, use the abs method to calculate the absolute value of the z-scores and create a new column, outlier z, to show whether the absolute z-score is greater than 3, represented as a Boolean value. When executed, we can obtain the following result. If the outlier z column is true, it means the absolute z-score is greater than 3, and thus the observation can be considered an outlier. However, all the rows show false. In other words, this method does not detect any observations as outliers. However, as we saw in the histogram, there seems to be some outliers. This happens because the z-score method is appropriate in cases where the data follows a normal distribution. Since this data is not normally distributed, the z-score method may not effectively detect outliers. The IQR method is effective when the data does not follow a normal distribution. First, calculate the interquartile range. The first line calculates the first quartile, representing the lower 25% of the data. The second line calculates the third quartile, representing the upper 25% of the data. The third line calculates the IQR by subtracting the first quartile from the third quartile. Next, to detect outliers, we define the lower and upper bounds. The lower bound is defined as the first quarter minus 1.5 times the IQR, and the upper bound is the third quarter plus 1.5 times the IQR. Any data points outside this range are considered outliers. In the next block, values smaller than the lower bound or larger than the upper bound are selected and stored in a new column called Outlier IQR. This new column contains Boolean values, true if the value is an outlier, and false if the value is not an outlier. By executing the code, we can obtain this result. The largest value is identified as an outlier. By using the IQR method, data that was not considered an outlier by the z-score method has now been detected as an outlier. A box plot is a method of displaying the distribution of data based on 5 summary statistics. These 5 statistics are minimum, first quartile, second quartile, also known as the median, third quartile, and the maximum. The whiskers of the box plot extend from the first quartile and the third quartile to a distance of 1.5 times the IQR. Data points that fall outside the range of these whiskers are displayed as dots. These points can be considered outliers. Therefore, A box plot enables us to visualize outlier detection using the IQR method. However, outlier detection by visualization can become subjective unless we apply statistical foundations such as IQR. Additionally, it is more efficient to use statistical method and input Boolean values indicating whether each data point is an outlier, because by doing so, we can move on to the subsequent data analysis directly. Visualization is effective as a tool for reviewing the overall distribution of the dataset to determine the strategy for outlier detection. For example, using visualization, we can consider which statistical methods we should apply and how to define outliers, such as whether using 1.5 times the IQR or 2 times the IQR is more appropriate. Although the outlier detection methods we have discussed so far are common, simply using them can sometimes result in failing to detect outliers properly. I will explain such pitfalls in the next section. Thank you for watching. Please thumbs up and subscribe to my channel.